back to my YouTube channel. This is the second part of designing a social media app where we will be designing a post service and it will be using a distributed counter. So this distributed counter is itself a separate design which you can learn from this video. Okay. Let's start with our requirements first. First one is functional requirement. So first requirement is that we want to do CRUD operational post. Post can include images, videos, just the text, caption, anything. Okay, so we can do a CRUD operation on that. Apart from this, if we want, we can reply on any post or comment on any post and reply to a particular comment as well. Third is if we want, we can if anyone can like anyone's post, and if he's liking, the likes count, total likes count should be present there. Okay. Now coming to the non-functional requirement, our design should be highly scalable and highly available. So this is the most important thing. Apart from this, the important part is if there are millions of operations happening on a particular post, it should handle that and it should scale automatically. There shouldn't be a bottleneck. By millions of operations, I mean there can be millions of likes coming, or there can be millions of people commenting or replying on a particular post. So yeah, let's start with the design part. So this is the very basic design which anyone can come up with. Here we aren't doing anything special. If you have watched my previous video, you can come up with design by yourself also. So what we are doing is we have this post service which are all the traffic will come and it will be distributed evenly by a load balancer. So this post service will be responsible for uploading new posts, second getting that post, deleting, or if we want to updating that post also. Okay, so how we will be doing the upload part, because get, delete and update is much simpler. So let's see how we'll be doing this upload part. So for upload part, I have created two APIs. One is upload and one is save. So let's see what these APIs do. So our post service will get a hit on this upload API. So this API will do it will just upload a particular file. It can be photo or a video on an S3 bucket. Okay, and just simply return that location back to the front end, and now front end will hit our save with that particular location name in the request and hit our post service in and hit this save API. So now why we have divided into two APIs? We could easily have done this thing in one API, like uploading it and then saving it to DB. So by saving in DB, what it will do is it will also generate a post ID. It will save its post location in the database, and also all the metadata which is required, like captions, any other hashtags are there, anything to whom this post is being tagged. So there can be n number of metadata which can be saved in the DB. Okay, so why we have divided it into two parts? Because there can be time where image file is big, so it can take time, and similarly DB operation is also a heavy operation. So I didn't want to club these both heavy operation single API. So I have segregated it between two APIs. One will be responsible for just upload and one will be responsible for creation of DB entry. We can scale, we can also handle this responsibility differently by different APIs. So yeah, it will be easier in future if we want to scale something like this. Okay. So yeah, so we are clear on this part, why two APIs. Now for reading from database, we have one middleware cache also. Most popular posts can be cached here. like if there is a post uploaded a popular celebrity, people definitely would want to read that post very frequently. Many people will be doing that, so we can cache that. Okay, so that is why I introduce a cache. And for database, I've used a SQL DB. It is simpler. We don't have a architecture or data model where are not sure of the what type of uh, what columns will be there, or not so we are pretty much clear what all data we want to save. We have a definite structure here, so that is why I've used SQL, and it will also help us in getting consistency. So if we want any part of that, we can use that consistency also here. So we can use master slave architecture for scaling this database. Okay, so yeah, let's see how DB tables look like. So for now, I've created three tables: post, like, and comment. In our post table, we will be saving the URL or the file location. We can generate URL on runtime also. Secondly, which user upload that post, and what are the like count. So this is not the mandatory field here. Okay, so if we want, we can remove this. It is not a mandatory field for now. So yeah, so similarly with like, we have ID of that will be a primary key, post ID, and user which is liking that particular post and at what time it is being liked. Similarly with comment, for which post this comment is, what is the content of that comment, and for default, by default, parent ID will be null. So if someone replies on a particular comment, in that we will be saving it as a comment only, but it will have a parent ID of that parent ID will be a foreign key of that comment for which reply has come. Simple. So it is very simple. uh, Comments which have parent ID are actually replies, and which doesn't have parent ID are normal comments. Now comes to the part how we will be calculating this, like how many likes are there for a post. So for this, first approach is, as soon as there is a get request for this post, what we can do is we can just count how many likes are there for this post by a query like select uh, count star from post. Sorry, select count star from likes where post ID is this. Okay, but there is a problem. Like, it is good for if we have low traffic, but what if there are millions of likes? So are we going to read that table for millions of likes? Definitely no. Although there is, we can have one index on post ID, but then also it is not a good approach, and it will most of the time the API, the query will time out. So most of the time we won't get the count. So what is the second approach? Second approach is we just simply introduce one new column here, which is likes count. Okay, so as soon as there is one entry in this like table, we will be incrementing this like count one by one. So what we can do is we can just have a lock on this particular row, and for that we can increment it. But again, it will create a bottleneck. How? Let's suppose 100 of people are liking one post at same particular time. So one uh, first person will acquire lock, rest have to wait. And so all this will be a fast operation, but then also the person which will be acquiring lock at last will have to wait a long time, which is not good. So the API can get timed out. It will always create a bottleneck, and this approach is not scalable at all. Okay, so now what else we can do here? Um, Before coming up to a solution, I want to tell you there that these two approaches also have one pro, that pros, um, that it is giving you like count in real time. Okay, Okay, what I mean by real time, as soon as someone likes you and you hit the get API of that particular post, you will get the real time like. Obviously, only if you are not saving it in a cache, since if the data is in the cache, it will be written from cache itself, not from DB. So yeah. So what no, the question here is, do we really need a real time likes count? I don't think so. Like if I'm liking some post and after 10 seconds maybe my total likes are being counted and shown to me, I'm okay with that. Okay, not real time. After a minute also I'm okay with that. Okay, so real time count is not required here. So what else? So what we can do here? So I want to give you a hint, like when things we don't want real time, we implement some messaging queue. For now, we are using Kafka. Okay, I will create a separate video how and why Kafka is being used by most of the companies for designing distributed systems, how Kafka internally works. So I will be creating a video soon for that. Okay. So now why how Kafka is being helpful here is, let's suppose I get a request for a like, so it will have which post I'm going to like and which user and at what time. So what I'll do is I will simply push a message in Kafka. I won't wait uh, for the I won't do anything else. I will just simply push a message in Kafka. With this message format, it will have post ID, user ID, timestamp. This message will be picked by this consumer. Okay, and this consumer will simply write this data in DB. Why I am not doing it in the API itself? uh, Simply because it will increase my API latency and things like that. This can be done in asynchronously also, so it won't hamper anything. And although we are pushing this message for counting also, so we can just read from that there, or read that message from consumer also. Now second part is how this count will be done. So we can use Flink here, Apache Flink. What this Flink do is it will help us in batch processing. What I mean by batch processing is, let's suppose I am getting for uh, uh, I was I am getting post one. Uh, yeah, for post one I got one like at T1. For post 2 I got at T1. Similarly for post 1 again I got at T2. So instead of count for post 1, as T1 and T2 can be milliseconds also. So instead of counting directly from here, this Flink will process this message in a batch. uh, in a batch, I mean there can be two kind of batch. First is time based batch, like I will tell my Flink to process all the messages coming in 5 seconds, consider it as one batch. Or I can say like consider 1,000 message only for a single batch. Okay. And we don't have this time based thing, or we can come up with a hybrid approach, or like if 1,000 messages are there, or 5 seconds are there, we can pick any one first. Okay, so now if we are going like, we will be uh, batching it for 5 seconds. Okay, so in first 5 seconds I got three messages. So what it will do is, it will uh, do a count in memory. For post one, it will see one enter is there, it will be doing like in memory count. Like for post one it will be become one. Now for post 2 it will become 1 again. Now post 1 is again come, so it will become 2. So now it has done its batch processing. Now it will simply go in DB and increment this value of like. Okay, for now it can have a lock. So likes, there are one in 5 seconds we get 1,000 requests, and it is for 10 posts. Uh, uh, it can be for n posts. Okay, but this Flink is also have multiple instances. So maybe there are three instances. So this post one is being incremented by all three at single time. So now there are only two people waiting for lock apart from this first one. Okay, so that is much more scalable than millions of people waiting for like one post at one time. Okay, so yeah, like this Flink is very helpful in batch processing. This uh, this mechanism is used for distributed counters as well. This is what we are doing with Flink, is doing a distributed counting. It is the same phenomena which we use in uh, counting how many visitors are there for a particular web page, and also for how many views they are there for one video, YouTube video. You'll always see that YouTube video view count is also not real time. Okay, so there is some lag, and that lag is expected because we don't need real time views. Okay, so this is the real time counter which will help us in counting number of likes. I will be making a detailed video of internal working of Flink, of Kafka, why, when, and how to use it. So stay tuned with all my upcoming videos. And if you want a special any system to be designed by me, so do let me know in the comment section. I will come up a video for that also. Till then, take care.